Want to get to Nearpod? Okay. So for today, we're going to be covering RAM. It's obviously called random access memory. It holds the data instructions used by a processor of a computer. As we learned earlier or briefly, RAM itself is part of the processing power. RAM can be upgraded and replaced. In this session, we're going to learn about the considerations we might take before we upgrade and install new RAM. We're also going to learn how to install RAM and how to troubleshoot and fix when necessary. Overall, our main objectives by the end of this session is to be able to define the system's memory and describe the different technologies, articulate the process, including the key questions to answer when upgrading it, determine how to select and purchase the correct modules, summarize the process of installing it, identify your common pitfalls, be selecting or installing the actual memory, and the problems that may come up with memory. Random access memory holds data instructions used by the CPU, which is the central processing unit. And that, my friend, is a cue to pause here for 5 minutes. Please pause the recording. Towards. So,
Who else is whoever has the
yeah, I
host?
believe, yeah, they started it. Thank you.
Okay.
So now, as we were about to review the key points overall for random access memory or RAM. It holds the data instructions that's going to be used by the CPU. As we learned, CPU stands for Central Processing Unit. RAMs can be both static, which is considered SRAM, and dynamic RAM. Dynamic RAM includes obviously our new modules that are out there. You have your DIMMs, your SIMs. When upgrading memory, one must consider the total RAM installed currently, the memory technology that's going to be used, the speed of the actual memory that it can handle, the if it can actually take ECC or non-ECC, which we'll be covering in this actual presentation, knowing what's the difference between the it's a CL rating, the single, the dual, the triple quad channels themselves, connectors inside the actual memory slot, and also we'll be covering the process for installing RAM and will vary depending obviously on the model itself. If it's a motherboard for a regular ATX board versus an actual laptop, that will obviously make the SODIMM versus the DIMM modules that are out there. We're also going to be looking at the common RAM problems, which include slow performance, application may refuse to load or even be unstable itself. And obviously, other ones that we have is insufficient memory issues. That is catastrophic a lot of times when the user themselves is a high-end user and doesn't have enough memory to be able to handle it. Lastly, we'll be covering which is the RAM problems themselves that can be resolved through troubleshooting and hardware repair. So, what can we use overall? Adaptability and persistence is a must. With all these types of memory that we're looking, we need to be able to adapt. We have to be persistent because of the change that's going on consistently in technology. As I stated in the beginning of this, welcome to the first day of never stop learning. Believe it or not, this is a continuous and a must if we really want to be in this. Obviously, the actual aspects of what a RAM is a RAM, what a CPU is a CPU, but the technology just gets more and more advanced, and you must obviously understand the new stuff that's coming out. For instance, way back when ECC and buffered memory was not available, neither was the DIMMs. The SIMs were available, but the DIMMs weren't. So we need to understand overall the key points here. Kevin, can you read to me the key points of or terms, sorry, of memory, these that are here?
Volatile memory loses its contents when the power is turned off. Non-volatile memory retains its contents when power is turned off. Unbuffered memory deals directly with the chipset controller. Buffered memory contains a buffer to help the chipset handle a large electrical load if the system has a lot of memory. Single-sided RAM has chips on only one side of the stick. Double-sided RAM has chips on both sides of the stick.
Yeah, that one's actually tricky, depending who you ask. Thank you very much, Kevin. The double-sided RAM can be actually double bank, which is only really you'll see the memory chips on one side, but it actually is using double bank, or in other words, equivalent to it being on both sides. So this double-sided RAM itself, it holds memory on both sides, or it could be just they're talking about the actual banks itself. Another thing we see here is there's volatile and non-volatile memory. Can somebody tell me what would be a volatile type memory versus a non-volatile memory?
RAM could be volatile.
RAM is definitely volatile, very volatile.
The non-volatile is the hard drive.
Hmm, we're talking about memory wise, so let's stick to memory instead of other units. In reference to memory, what type of memory is there out there from what we learned so far? There's RAM and there's one other one that we learned, the basic ones. There's two of them, right? At least,
RAM.
thank
Maybe
you.
ROM, yeah.
Read-only memory, right? And would you say that is read-only memory volatile or non-volatile?
Non-volatile.
Non-volatile.
Right, from what we can see here, right? It retains its contents when you turn off the power. Now, is CMOS, is that volatile or is that non-volatile?
Non-volatile.
Non.
Okay, we got two nons.
It's volatile because it
I'm
needs
not
a
on.
battery.
Yeah, the battery.
Yeah, it does trick you, right? It does require a battery, therefore it is volatile. The moment that you remove the power itself and remove the battery, the whatever the ROM placed inside the CMOS configuration is gone. That RAM loses its information. But now we can kind of get what volatile means, hopefully, and non-volatile. In reference to unbuffered memory, that's in reference to it itself. It's either buffered or unbuffered. Anyone know what that means by buffered?
Well, there's like something in between it. Like that's what like a buffer is.
Exactly. It's another fancy way is it's got more memory. You have the memory itself, but then you have the buffer of what's going on. So instead of it only doing its job here, it has a buffer of what's about to happen inside the CPU. So everything that's always going through, there's an extra set of memory that it's using to be able to buffer everything through. So it's much more fast performance in reference to that buffering. At the same time, it should help with the actual, those are more towards the high-end servers that wouldn't be on a regular chipset. Single-sided and dim, and the other ones, which is the sims and the dims, we'll get into the actual details of that in a second. As for memory definition, Joshua, help me out here.
Okay. Definition of memory. Memory definition. Area within the computer where information is stored while being worked on. Information is stored by using on or off switches, where on equals 1 and off equals 0. When strung together, these switches can represent large numbers and code values.
Definitely. So what they're trying to tell us here is basically, as we learned, everything is either zeros or ones. What the RAM has is what's happening now. What was just now, then is gone, is no longer now. Therefore, if it's not now, it's not happening now. What I'm trying to say, hopefully everybody's seen Spaceballs and seen that little skit. What is in memory is in fact only what just happened in that little nanosecond. It is completely refreshing at all times what's being sent from the actual CPU to the memory to the hard drive. Therefore, whatever you see here in my screen, it continuously refreshes, letting it know what represents every single dot in this screen. There is a just like the resolutions of 800 by 600 high end, that means how many pixels, how many of these little squares are on my screen. It must instruct the video card with that information, including this annoying little mouse movement that's going on here, that's pounding the memory and the CPU just to be able to do that. As for my actual file, if I want to go and get an actual file, that's going into my actual hard drive. If I want to go into my hard drive, then that will bring it up into the memory so I can see it now, and it will update and refresh the hard drive as I hit the save button. Although I'm pretty sure it's happened to many of you, if you do not hit save, whatever was in your RAM and it crashes, you're pretty sure it's happened to everyone, it's gone. Why? Because it was in the now and it wasn't in the then now. So therefore the now is gone and the then now never got then the information. Your hard drive only contains it when it is written to it. Therefore the RAM will only keep the information that's there. Even the back end, whatever's inside your actual Explorer. Therefore, if I have a plethora of applications open, does anyone know what the RAM does to be able to alleviate, or what does your computer do to be able to alleviate problems with RAM?
Slows down.
Besides slowing down, is there something else that it can do to be able to continue to run?
Hygiene and using virtual memory when it's not enough.
That is correct. There is a page file that Windows creates, which basically mimics RAM. And what happens is that whatever is not in the forefront, in other words, in this case right now, you see here that I have this and I have about 5 or 6 other applications open in the background. This will only be impacted or seen in the RAM when I bring it to the forefront of my computer. Everything else that is in the background is housed in that actual page file. It mimics RAM to alleviate when you run out of actual RAM, it creates that fake RAM for the computer. Everything's written in there and is a temporary file. As soon as you try to bring up that application, it tosses it instantaneously in nanoseconds into the RAM to be able to show it to you in the forefront. Never stays put. If it's in the front, it must be in the moving action. It's data in motion. It was what we call data in motion, not data at rest.
Same thing if you have like a split screen for things and you have like
If you have
multiple things.
yeah, if you have split screen right now, I have a lot of things because I have 2 screens. So I have this and this other one, plus I have all the other applications. So everything that's in the background is basically on that page file, and anything that I have here in the front is on my RAM right now, ready to go. So the more you have open, the more things you have utilizing the RAM, the more RAM you require. That's why the
Have
high-end gamers require more memory. The high-end people that create videos or editing, those people require a lot of processing and memory.
I have a question.
Mhm.
So it says about these switches using off on and off switches.
Mhm.
Are those physical switches like you'd see, let's say, on a light bulb, a light switch, or
You could always think of them as that. That is the original switches. I'm not sure if you ever saw an original computer, but it was an off and on, but it is a off and on internal switch in it. It's either a 0 or a 1. It's a switch in there. It's an electronic switch that's turning on and off. The electricity must flow. Either the pathway is open or it's closed. To close the circuit means that it's a 1. To open the circuit is a 0. On or off. It's stored with information in volts, right? So it puts its information in there. So when it sends the information, it has to either write a 1 or a 0, so that when it adds this information, when it grabs all the bits together to create 1 byte, which is 8 bits, it creates information. Based on that information and whatever application you're using, it gives you a result on your screen. All zeros and ones, no matter which way you look at it. Questions, doubts? So let's see who can help us out here. Arturo.
Read-only memory or ROM. Non-volatile and permanent. Cannot change instructions unless it's replaced. Stores systems information. Post routine, BIOS programs, boot instructions. Types of ROM chips. Programmable ROM or PROM. Erasable programmable ROM or EPROM. Electrically erasable programmable ROM or EEPROM.
Thank you. So as we see here, these are the read-only memories that are available. As we know, it is non-volatile. It should be stored there at all times. There is some of them, as we see, that are upgradable. You can go and update them. But usually the ones that we go into the computers and with the regular desktops, they don't have the fancy EPROMs and EEPROMs. Those would be on your high-end servers, performance type machines. That would you would want that in there. There's not going to be a reason to have that on a cheap version. Questions? Doubts? Everyone understand what is post routine? So what is the post routine? Anyone? Post. Hello.
Like when
Post
it's
is
booting?
a way to check the system and what is like installed and what is there, all components when the computer is just turned on. At
Okay.
least I think so.
And does anyone know what post stands for itself? The letters
Or
post?
on self-test.
That is correct. So it's basically in itself is as both of you just said. She gave the definition, but if you just listen to the word itself, it tells you exactly what you just said. It is a power on self test of the unit. That is a recorded information to know how to do it. And then you have the actual BIOS program, which is the GUI representation, and a new one is the UEFI ones, and it has the boot instructions. All that is stored in there. Questions, doubts on a actual ROM chip? All right. So adaptability is a skill of changing your approach to address a variety of needs and demands. You learn so many different kinds of RAM right now and ROM technology. When you become an IT professional, can somebody tell me when you're asked at work and speak about the knowledgeability of many or even all of them, what is it that you require from adaptability itself? How does it help you? All these different types of RAMs, ROMs that you're learning, how can adaptability help you as an IT professional? And why would you require it?
Because you'll be able to stay current with anything. If something else happens, you'll be able to adjust your, your learning pathways, that kind of thing.
Yeah, and we need to be able to adapt to any given situation. If it is a the EPROM, PROM, whatever it is that you need to learn, you're also going to learn now what is random access memory. So in learning this, we're learning another type of memory. This memory is one of the hardest ones for people to understand because there's obviously the dynamic one that we see here. We have our static. We pretty much understand, I think, what CMOS is, and we have our synchronous. So Ayana, can you help me out here with the definitions of these?
Dynamic RAM, DRAM, stores data for only a fraction of a second before losing it. To maintain stored data, the system must constantly refresh DRAM. this reduces performance. DRAM is packaged as SIM, single inline memory module, or DIMMs, dual inline memory module. Static RAM, SRAM, retains information without the need for refreshing as long as the computer's power is on, volatile. CMOS RAM is memory that uses a small battery to keep its volatile state always retained. It stores almost all motherboard configuration data. Synchronous DRAM, designed to operate at clock speed. If the system bus is 100 megahertz, then SDRAM matches that frequency. SDRAM is referred to with the PCXXX, where the XXX is the bus speed.
Thank you. So the old ones here, the dynamic RAMs and versus the SD RAMs, the synchronous ones, we're going to learn these. As for the static RAMs, as we see, those retain without needing to refresh. So that one doesn't actually let go or continuously have to be refreshing itself. It will retain the actual information versus the dynamic one is consistently refreshing to be able to retain the information and keep you up to date. The DRAMs, which have now the single and the dual inline, we'll get into those details itself. As for the synchronous DRAM, we're going to learn exactly why that came up. It's used obviously in the most modern systems, RAM that actually holds the instructions in that is preparing for the actual CPU itself. It can go through the Northern Bridge or the MCC itself so that it doesn't waste so much time instead of it actually being having to go through any other route or slowing itself down. It actually ties itself to the system clock and hence making sure that it is in the exact same speed as the bus compared to the other ones where there was impact on the older ones where it wouldn't synchronize. So it did create latency and extra issues with the old boards. Questions so far? So your old form factor modules, you have your actual DIMMs, your SIMs, sorry, your SODIMMs, and your micro DIMMs, depending obviously if it is for laptops or little notebooks or the size of the actual unit. So you'll notice here you have the DIMM, which is the dual inline, while the SODIMM just means small outline DIMM or dual inline memory modules for your laptops. Overall, your micro DIMMs are for your little sub notebooks or either smaller devices. You can see there is a variance, huge variance in the actual size. Obviously, to make up space because of the little micro ITX boards, those things get smaller and smaller, and then therefore require smaller modules. Questions or doubts? If we notice here in this banks, this here has a DIMM 0 and a DIMM 1. It doesn't have multiple channels. Everything is a black. Therefore, I only have one channel here. In the DDR, this is obviously versus the old ones. This is the new DDR chips versus the old chips that are out there. The old chips that were prior to that could only go to the actual speed of the clock. As we see here, the speed of the actual clock in this first row here is 100, while since this is DDR, it's double data rate. Hopefully some of you have seen music or understand a little bit of music. You could always pretend that your old modules were always on the clock. So it always went once, right? So instead of only going once, you can consider that a quarter note on a beat. The DDR is equivalent to an eighth note. So instead of just talking once or listening once, it now talks double, both on the top end and on the bottom of the given beat. It's able to talk. It's considered DDR because of the name. That's how cute it is. Now, from this, you'll see that since the clock speed, the crystal that's on your motherboard, the little gray little doohickey with the two little antenna, the quartz guy, here's his different speed. So the bus is at that speed. With this new technology, you'll notice just as simple as multiplying whatever the clock speed by 2 gives you this module's rating. So this is a DDR 200. To be able to accomplish and understand what is the rating for a PC, everything is calculated in bytes. Anyone remember if this, what is the amount of bits in a byte?
8 bits.
Therefore, if we take this number, which is 200, multiply it by our friend's number, which was 8, we should get a number that's considered 16. Hopefully, if we remember a little bit of math. So I'll go back. The clock, who's the original bus, is at 100. This guy can double it because he's able to actually talk twice throughout the clock, right? That gives me double the speed. So this is the module itself, and here's the PC rating. It's exact same number. Nothing's different. It hasn't tweaked anything. That is the only variance is that when you see a label that says DDR200, you must understand that if it gives you DDR, you must multiply by 8, whatever that module's number is, to get the PC speed rating. That gives you the bandwidth of megabytes per second.
I had a question. So say like 133 megahertz in the DDR266. For the math, how'd they get 2100? Because we multiply by 8, it's different.
Okay, let's grab our friend here. See what they did. So you're saying that, what was the number? I'm sorry. It was 266, right? And I multiply by 8. If I multiply it by 8, I get 28, 2128. So apparently they just took the zeros out. They just rounded down.
Much like they do with your memory and stuff like that, where it's like 1 gig is like 10.66.
Yeah. So they're just rounding down. It is still multiplying by 8. It's supposed to be 2128, but unfortunately they just took off and just rounded down.
Mike, you wouldn't want to remember 2128, sir. You'll want to remember 2100.
Yeah.
It's easier to hold on to that number.
Yeah, and plus they're gonna give you these numbers like this. They won't give you 2128. They'll give you 2100. Therefore, hopefully, if you get 21 something with your calculator, you'll remember that it's got to be 2100. I hope that made sense. Doubts? So our regular one was the regular. This is the DDR. Now we can see what is dual channel technology. With the use of DDR, now I can use the capability of 2 channels. You remember I was saying I'm talking twice, right? There goes my talking twice, my reds and my black, either the red or the black. Not sure if you guys actually knew that. That is how we got the double the throughput. I have double the channels. Obviously, it requires to both memory modules in pairs must be with the exact same clock, throughput, and clock cycles. Clock speed, throughput, and clock cycles. They all have to match. If it doesn't match, it won't get recognized. Maybe the first one on let's say this one here is 0 versus the 1 here. This one will be recognized, the other one doesn't.
I have a
Question on
question.
dual channel, yes.
So if there's only if the motherboard only has one available slot or a channel or whatever, then you couldn't use the DDR SDRAM, right?
The DDR has the capability, DDR SARAM, your motherboard would be for that type of RAM. Therefore, it wouldn't be the old one where it has just the static one channel. Now I lost where it was, somewhere around here. It was only one bank. Somebody help me out. There was only one bank instead of being the different colors. You saw it earlier. It's in one of the slides. Sorry, it only had 2 black ones. It didn't have a black and a red. Only had one channel, one bank. That's the old motherboards. With the new one, which is for the DDR, this modules, they have the dual channel. you're going to see real soon, though, in the DDR3s and the DDR4s, they're going to do the exact same things, but then they go from dual to tri to quad to
Thank
be
you.
able to increase the actual throughput. Good
I
question.
have a question with the previous, if you go back one.
Hmm.
Yeah, on this one. So the PC can detect that it run with 100 uh, clock as bus. Is that adjustable or?
That is the motherboard clock speed. That's the quarks. They're just
Mhm.
giving you different models here. And so that you could understand if you have this model on your motherboard, this would be then considered a DDR speed rating because of the fact that since the DDR is double the amount of whatever the clock is. So this is my motherboard. I have 4 different models of motherboard. Since it is a DDR, it'll be double the amount of whatever this here. So I multiply this by 2 and I get the 400. This is the motherboard, and this is what what the actual memory does.
Can
It's gonna
increase
make more sense
the
now when we
time.
get to the DDR2 also in the DDR3. It kind of repeats itself, its pattern. I'm sorry, there was another question.
Can increase PC speed more than 16. Is that
There's
for?
nothing to change. This is bought. This is
Oh,
static.
okay.
This right here is static. This is the motherboard itself, the bus, the crystal, the little guy that has the 2 little antennas. It's equivalent to what's in your clock. So you bought yourself either a Rolex or a Polex. So depending on which one you bought, that gives you the actual bus speed. That is the how fast the motherboard can run.
I have a question.
Remember, hmm
So if these crystals, these quartz, they can only spin at a certain speed, then why do we have them so where you can upgrade the speed to like from 100 to 133? Does the technology get better or does the crystals spin faster?
the
It's
crystal is able to handle higher speeds. Correct. It's set at a certain speed.
it's a consistent and predictable rate based on
Hmm.
the amount of energy put through it. It's not necessarily a set speed for every single crystal. You just know consistently it's going to always cycle at the exact same speed.
Okay, thank you. That clears that up.
Any other questions? So it's a simple. So here's your clock or the motherboard. Then since it is a DDR, we just multiply whatever the clock can do by 2. That gives you the DDR speed rating. The exact same number or the same equivalents just to find out what is called the PC rating, which is your megabytes per second. You just multiply that by 8 and it should give you the number that's here, or at least close to the number that's here. Next, as we stated a moment ago, is our dual channel technology. It uses a 2 DDR SD RAM sticks to increase the actual throughput. And obviously, depending on the motherboard itself, if it has the capability or not. Usually, it is as clear as day, and it will tell you with these little colors to let you know which bank is which. Next is DDR2, not to be confused with DDR. It does obviously require less power. The more technology there is, the same thing is going to happen here. This increases the clock by doubling the input and the output overall. This doesn't speed up the RAM. Once again, all it does is just allows it to talk more in every beat. In essence, yes, it makes it faster. And that's because it's talking more, but not because the chip is faster, which is always confusing as hell. It's just able to send more things at the same rate of speed. So there, now that it's double the amount, we can see here again, your processor or your core speed is at 100. Your DDR, your old one, is at 200 here, but the actual modules, you'll see that it's at 400. The speed rating of the DDR2s is 400 instead of 200. And now I do the same thing. I multiply by 8 to get my PC rating, which is a PC2. If you'll notice, once again, they're making it cute, nice and easy. You should be able to tell what is a DDR and what is a DDR2, what is a PC module, and what is a PC2 module. If it's a PC2 module, that means it is a DDR2. If it's a PC module, it must be a DDR module. Any questions, doubts?
Can you say that last part again?
Yes. The naming convention coincides with each other. So the DDR2, which is the speed rating of the memory, is called DDR2 with its number coinciding right next to it. In this case, is 400. For the PC speed rating, that means how many megabytes per second, it has a PC2, which is equivalent to a DDR2. If we go to the other one, it said just DDR with its number and PC with its number. So that little 2 lets you know that you're already dealing with the second generation technology, which is double the amount of what a DDR does, which is actually 4 times as faster than the actual clock. You see, 4 times faster than the actual clock. A DDR goes twice, a DDR2 goes 4 times as fast, or 4 times as throughput, 4 times as much as throughput. I always get that name. Question? Doubts? So a
Michael was
DDR,
asking a question.
go
Sorry,
ahead.
Michael was asking a question in the chat, which is pretty interesting.
Okay.
As the
What was the
DDR
question?
number goes up, does that make all the previous DDRs less compatible?
Every single module is not compatible with the next. That is correct. They purposely make the notches and or the amount of pins different. Makes it impossible to you to be able to do it. Therefore, they do require that always when you're looking into, which we're getting into that when we're going to install new RAM or upgrade, that we make sure we look at the actual manual or the existing memory that's there to see what type of memory that is there. We would like to also know what is the capabilities of that motherboard, because it could be a DDR3, but we don't know what is the highest amount of memory that that motherboard takes. So now we went into the DDR3. It's obviously higher speed, more efficient. Again, lowers the consumption of a input of power, which obviously uh, is a good thing because of the fact that your PSU or your power supply unit is not getting pounded with the amount of watts. It doubles the buffer from 4 to 8, as we notice now. So instead of being just 4, it's 8 in one beat. 8 in one beat. Remember that up and down, just like in music. So now it can go 8 times compared to it's pretty darn quick, right? So you could always think about DDR3 now that it is 8. So if I had 100, now I have my DDR3 is equivalent to 800. And if again I multiply 8 by 8, I have my PC rating, which is 6400. All means the exact same thing, just to let you know how fast each thing is going. Another great feature is that the capabilities of this chipset went from being 512 to 16 gig modules. The DDR3 supports triple and quad channel technologies. You guys understand what they mean by that quad? We talked about dual, right? So
Sure.
quad would be 4 channels. It's a lot of banks. Four pairs, right? It's a nice, beautiful motherboard. got to be an ATX most likely, right? If you want to be able to have that type of luxury, it's up to 4 different channels. Now the DDR4, which is the latest and greatest, once again, higher density, lower voltage, and now the modules go up to 512. Here, they don't even try to bother with the 100 megahertz because that doesn't exist for that type of memory. They just start off with the number of 200. Again, in this case, if you'll notice, we're already from 200. You get 8, you have there, and then 8 times this guy gets you there. Questions? Doubts?
What does the MT stand for?
1600 MTs per second. You're saying the bandwidth? That is a good question.
Microtransactions.
Thank you. Bits? I'm pretty sure, no? Isn't it the same or equivalent to bits or no?
I'm not sure on the conversion on it. I just remembered it was microtransactions.
Okay. Any other questions, doubts?
Yeah, I had a question. So when you're talking about like dual channel and quad channel, and you said like the red and the black, does that mean like one is for input and one is for output, or I didn't really get that part?
The colors is to let you know which ones are in pairs so that when you buy the modules, you know that that channel, those 2 memories modules must be exactly the same speed, same clock cycle, and same exact module. They have to be gemelos. They could be different manufacturers. They can care less about a manufacturer of the memory module, but they need to be in sync. Both of them need to be able to talk at the same rate.
So in that case, you would need to buy 2 DDR2s, like in that instance.
Yeah, whatever you have there. If it's 2 DDR2s, if the motherboard is a DDR3, it has, let's say, 3 channels, then you can put most likely 6 modules in there. And each channel, each module has to be, at least each pair has to be exact same. Now, all the other channels can be different sizes. As long as their pairs are the same, it doesn't matter.
Oh, so you can have like a DDR2 and then like a DDR4 right next to it?
Most likely not because of because of the motherboard won't have that. The motherboard will support only one type of memory modules. And since one is not equivalent to or backwards compatible, it won't. What you could have is, for instance, maybe a DDR 1600 in the first bank. So the first pair is DDR4 1600, and then your second pair bank could be a DDR4 2400. They're both DDR4s. They're both separate speeds, and now you could just each bank can be running at its own speed. For an example, just trying to say, or even the size itself. Just trying to give an example. It could be a bigger size because this is a speed. So there could be a 16 gig module in 2 banks, and then maybe 2 32 gig modules in the other bank.
Okay. So the key thing here is that both pairs have to be the same speed.
Yes. Speed and size. Everything has to be exactly the same. They have to be twins. Doesn't matter if they're not the exact same manufacturer, but they have to be exactly the same.
Gotcha.
Any other questions, doubts? All right, so we'll see a beautiful picture here. As we can see the SD RAM slots, you'll see a little line coming down. This one's a little bit more off-centered. This one's way off-centered, and then this guy's somewhere in the middle. Doesn't matter which way you look at it, it purposely is impossible to be able to fit a DDR, a DDR2, a DDR3, or DDR4 intertwined to one or another because of the fact that although they may look the same in the picture, that slot in the middle makes it impossible for you to get it Humpty Dumpty with a star or a circle mixed all up. Questions, concerns?
Do we have to memorize where those slots are relative to one another for the test?
I'll be honest, I got a question that involved that. It was only DDR 1, 2, and 3, not DDR4, but I did get a question for that where I saw a picture and they wanted me to pick the right one.
Hold on.
Yeah. Yeah, the easiest ones are the 1, 2, and 3 because of the fact that the most right is this one. Then he comes towards a little bit to the middle, and then the one all the way to the left is this guy. The hardest one to find would be the DDR4 since he is pretty much in the middle, in between the 1 and the 2. So you wouldn't be able to. Now, if they put all 4 of them, you should be able to tell which one's which. Just by looking at it, you should be able to hopefully identify that. That is, if you notice the pinout, I don't think is going to be much of a pain in the butt. They would show you something like this to see if you can recognize them. Similar to them asking you to be able to differentiate from a PCI and a PCIe and an AGP card in a video side. Right. So what else does RAM have overall? That, my friends, is that, let's see, Anne, help me out with this slide, please.
Hi, Diego. Did you say Dan or Ann?
Anne, please, Anne.
All right, thank you. RAM responds to electrical signals at varying rates. The delay in RAM's response time is called its latency. Latency is referred to by one of two terms, column address strobe or a clock cycle. The lower the latency, the better.
Thank you, Anne. So yes, so overall, the clock cycles or the CAS is one of the things that we should look at, just like in golf itself. The lower the number, the better. So we'll notice here in this one here, the module says that is a D3. So if anybody can tell me, what does that D3 mean to you?
DDR3.
Thank you. So then the 2133 tells you what?
The PC speed.
The DDR
PC.
speed, right? The 20 DDR, because it's telling you D3, so that already tells you it should be DDR3, right? And then it gives you 2133. So if I wanted a PC rating, I needed to multiply that by 8. Do we agree?
Yes.
Okay. Next we have here is CL6. So that means it takes 6 clock cycles for this memory to get completely reviewed. So that means from one end to the other, it requires 6 times for that clock to go around. We did understand it. I think it was 1,000,000 per second or some ridiculous amount. But anyways, so looking at this picture, if we look at the top one, one's a DDR3 2133, which is CL6. The other one is a DDR3 2133 with a CL9. Which one would you consider is more expensive than the other or faster than the other?
The 9.
CL6. The
Six, I feel like.
The 6.
Okay, we got 1 vote for 9 and a plethora for 6. As I stated earlier, yes, your CL number is equivalent to a golf score. So the lower the number, the better. I haven't found any modules that have a -1 as 1 under par, but that would be cute. But either which way, we have to understand that when it talks about clock cycles, the lower the number, that means the less times the clock has to go around to be able to read the whole module. And since both of them were the exact same speed and the exact same DDR rating, The only thing that changed here was the clock cycles, and in this case, yes, CL6 would be the better of the two. Next here is parity. This is another information that we have for memory itself. Obviously, this will be more into a high-end server or something like that. Elizabeth, help me with this one, please. You can help me read.
Okay. Parity is a method of ensuring data integrity. One extra bit of data to check parity, even or odd. MCC uses the bit to verify if data was correct. Cannot correct the error. Error correction coding, ECC, used in servers, is more robust than the parity method, detects errors by adding more information about the bits, corrects the errors on the fly. ECC RAM are slower and more expensive.
Thank you very much.
You're welcome.
So does everyone understand what parity means? Because if you did, you guys are geniuses.
Parity, it's like one extra bit on the memory that is either 1 or 0, and it's basically calculated the way that if if there is number odd or even in the byte.
Yeah, okay, let's play this game. I think that sounded very close. So for those that may still be struggling, let's play with a memory module here. I'm only going to play with a nibble. Everyone remember who a nibble is? I hope so. A nibble is what? Somebody define for me a nibble, please.
4 bits.
Thank you. So now that we have this memory, beautiful, you can see I can draw real good. Thank you. Picasso, I am not. Here's him writing his information of zeros and ones. Now, what the parity bit itself does is in fact keep track by an easy method of either deciding if it's going to be a 0 or 1 by creating a pair. It must be a pair. In this case, when I'm creating this last parity bit over here, right? Can somebody tell me if it is going to be an even number? If I add, I have 1 plus 0 plus 1 plus 0. What should I put here to make it a even number? Should it be a 1 or a 0?
0.
0.
Okay. So we could play this game again. I'll put here a 0, 0, 1, 0. What should be my number here for my parity bit?
1.
1.
Okay. Now that we understand that part, what happens is, for example, if this happens to be a 1 over here, instead of being the actual 0, so he sees 1, 0, 1, 0, 1, this parity bit lets it know that this part of the information that's here is useless, completely useless to me. It avoids the actual server from crashing, and it asks for the information again. That is parity. It won't fix anything. It just knows that that information is useless. Therefore, you won't get the glitch. You won't get a blue screen of death. You won't get some weird thing where the application is not running. Once again, these are things for high-end servers, things that you want to make sure they have performance, and it does create latency because of the fact that it's creating this extra little check. We need to understand parity because in RAID, in hard drives, this, if you don't got it down, you won't understand RAID because it makes it completely impossible to understand RAID. And it's because of the parity bit. Any questions on what a parity bit is and what it does?
But I have a question.
Mhm.
But you said that the parity bit would come in after, but so like for instance with how it currently shows, if there was a 1 and 1, it would make a 0 at the end. So I'm not understanding how it checks, because shouldn't it have become a 0 at the end here?
Absolutely not. When I came back, right? So I just wrote something to memory. But when I came back to try to pull it from memory, I read 1010 and I see this one. The memory is going to say, this is useless. I can't use it. It doesn't add up to an even number. CPU, hard drive, wherever I just got this, I need what was in address so and so. I need this back, whatever it was, because I can't tell you what was here. It's useless to me. That's all it does. Compared to other memories, will let you crash when something volatile like that happens. This is just so that it doesn't crash.
I see. I think I understand better now.
Yeah, I'm just showing you the what if scenario. So it wrote it the right way. It probably had a one over here, but when it came back to it, unfortunately, it saw that other number instead of the number that it should have used. So when it notices it, it's just going to erase it. Now, the variance between that and an ECC is that the ECC is able to correct it. It is able to say, hey, in this slot, that's where the one was. Very smart memory. Once again, more latency. Got to keep track of what was written somewhere. Requires more questions, doubts. So we'll recap. We had the parity one, which basically says the even odd. Then you have the actual ECC coding itself, sorry, error correcting, which actually checks for any errors and then fixes the actual errors on the fly. My friends, that was our little song. We can pause here the recording, please. Continue at 3. I got that control, just saw it. We were referencing last was in reference to parity check itself. Any questions in reference to ECC or parity memory modules?
I was just gonna say something really quick.
Mm-hmm.
These ECCs, the error correcting codes, that's kind of similar, at least in my mind, to the way that DNA sometimes works. There's things in your DNA that it notices the error and it swaps it out and corrects it on the fly.
Repairs, correct, on the fly. That's one interesting way to look at it. Guys, please open. Never mind. I think I have that. I forgot it. Keep on forgetting I have full access now. There we are. Should have everybody coming in. So next type of memory that we're going to be covering here is the registered or buffered memory. Let's see who could help us here. Let's go with Fadil. Please help me read this.
Okay, registered or buffered memory. Memory that has a register between it and the memory controller. The register stores bits of information in such a way that systems can write or read out all the bits simultaneously. It reduces the load on controller and allows the device to support much more memory than would be possible otherwise. It is used for servers. A possible effect is an introduction of latency and a drop in performance.
Okay. Any questions on the buffered memory? Do you understand its use and or what it does? So if we could just look overall at the actual memory module. Yes, that's me drawing again. You have your little chips here, right? Then it has an extra little buffered memory in the center to be able to take the flow of whatever's usually going here into this center one. You could always think of it as a little mini uh, extra memory module in the middle of it. Again, that's for high-end servers. Wouldn't be something that would be on a regular computer. questions?
Is that,
Mhm.
yeah. Is that what I remember seeing something in the book about I forgot what it was called, but it started like an S, like SPD chip or something. Like and like I have to like pull it up, but it was like something I think I don't know if it's related to that or not, but for some reason it reminded me of it.
SPD, I believe, is a serial presence something or other. It's serial presence detection. SPD, not buffer memory that I'm aware of. I don't think so. So next is the access speed. Access speed is the amount of time in nanoseconds that the RAM takes to provide the requested data to the actual memory controller. The memory controller is that MCC, that guy right in between, right? We also said that there is a North Bridge, but there is a memory controller on the high-end ones. They have these extra chipsets, again, to help with the performance, to help with the throughput, so that we don't have the latency of the information that's going back and forth. Ensures that add-on memory is the same speed as or faster than the existing one. Do not mix memory modules, as we said, of different speeds in the same bank. Check the motherboard specifications for the required speed. I can go and buy myself a Lamborghini, but I can't go and put it inside this little Datsun. Not gonna fit. Got to be very careful on what we actually get. And here is what we just heard a moment ago, the serial presence detect, or SPD. When the computer is booted, the SPD tells the basic input output, or the BIOS, all the information about the RAM, the module's size, data width, speed, and voltage. So he goes and he tells them, hey, look this up in your encyclopedia. This is what it is. Now you got it. You got your encyclopedia. Look for it. That is exactly how you're going to talk to them. That's the way you're going to do the zeros and ones with this guy. With that information, that's how he's able to tell what size your memory is, what's the data, speed, everything about that given module that you just put in there. Without the SPD, you wouldn't be able to do it. Hopefully that answers the question that you were asking for earlier. So serial presence detect. All it does is just pass the information to the BIOS. Questions? Doubts?
Does it work like together with CMOS, or is it something completely different and separate?
It gives the information to the BIOS, who eventually passes it to the actual CMOS for storage. But it tells the BIOS, right? So when you first boot up, it tells the BIOS who he is. Now he'll let's say if the RAM already existed, right? He'll go and check then the CMOS and say, all right, this is what this guy just told me, what the SPD said. Is that what was here? Yeah, that's it. All right, so let's keep on going. Now it was different. You always get prompted. It'll tell you, hey, hit F1 now because you just installed so much memory. Or hit F1 now because you removed so much memory. Because now the SPD went and said that there's here this, while the CMOS contradicts what was there. Any other questions?
So the SPD passes the information while the ECC informs the error.
ECC is error correcting coding, which deals with the ones and zeros that are being written onto the RAM module. The SPD lets the BIOS know the type of size, data width, speed, and voltage of the module. He kind of just gives them the actual information that he needs. This is part of that feature for auto plug and pray. This is how it does it. It says, hey, this is who I am. And now he'll go into his little encyclopedia and see how if he can actually talk to this guy. Does he have the capabilities to talk to this guy? Questions?
So that actually happens during the post test also.
This is part of the booting, yes. When it's going to do the post, only during the post. That is correct.
Thanks.
So I believe we'll be stopping here. Correct me if I'm wrong, and passing it off to
Lázaro. All right. So we're going to talk about when to upgrade your RAM. So the main symptoms that tell you when you need more RAM in general is it's slow. Windows usually gives you an error saying, hey, not enough memory. And a big giveaway for the exam, the hard drive is being accessed a lot. And I mean, the lights just keep blinking. That's also a test question you may get where it even says that a lot of activity light on the computer and it's related to the hard drive. The reason why is because virtual memory, which is right over here, is basically you can think of like temporary RAM memory. It's very slow. Very, very slow. So basically the hard drive, your storage drive, is acting like RAM. And your Windows is basically operating that known as a page or swap file. And as you can see here in the slide, that, you know, usually it's like about 1.5 times the amount that is installed in the RAM. So it will make its own virtual based on whatever percentage of RAM you have or what it thinks it needs. It does it automatically. There's a formula. You don't need to know the formula, but basically it will make its own recommended amount. And that only is used when you exceed your amount. So let's say you have 8 gigabits of RAM. You pass the 8 gigabits of RAM. Now your Windows is saying, hey, I need more RAM. I'm going to take it from your hard drive. And it's temporary, very slow, but it will work in a jiffy. And like Diego explained before, what you have in your foreground and background, meaning what you have active, unfortunately I don't have screen share. Diego, can you show like a forward image, like just a new image or anything, any new windows?
I could definitely try because I'm specifically only showing that window, but let's see if I could do something else. This should hopefully do the case. Can you see that?
Oh, now I can. Okay, so you see how Diego has his Word document out? Right now, that's being accessed actively by the RAM. But whatever he has that's being, you know, saved on his taskbar, like say, you notice that he has his TeamViewer open or he has his OneNote. Once he clicks and opens it, now it goes back to active RAM, and whatever goes back into the background is being stored in the storage area in the virtual RAM. That's only if you have maximized your physical RAM. So I know it's a little bit confusing, but it's best to see it visually. And then in the future, I'll be able to show you a little bit more examples too.
Yeah, you could always take note. The reason why it also needs 1.5 is because it needs growth space while it's going back and forth. As he stated, if you have 8 gigs, if it's going to throw something real quick and you're opening something brand new, it can quickly throw all 8 gigs into the hard drive, grab the brand new information and bring it up into the RAM. That's one reason why it's usually minimum of a 1.5. Once again, operating system does these things by itself. You wouldn't want to go and tweak this. You can tweak this, but you wouldn't want to go and tweak this unless if you know the exact specifications for the application that you're dealing with. This should be handled by Windows, not us.
I agree. You don't want to mess with that like I did. Big mistake. All right, so here's a good question. How much RAM does your OS allow? And also, how many and what kind of memory modules are currently installed on the motherboard? These are important questions to think about when you're upgrading or replacing. And there's other things you got to consider. You got to consider also the physical installment, meaning, hey, does this DDR1 fit in this motherboard? Are they compatible? Is this DDR2 or 3 compatible to my motherboard? The physical connections matter. As we were talking about, you have those little notches on the RAM, and it's important to know that that RAM has to be designed for that motherboard. And like Diego said, it's specifically designed to have that notch to prevent users putting it into the wrong motherboard, and worst case scenario, blows up. Worst case scenario. I don't know if that's possible, but I don't know. If users were able to shove that RAM in there, it's probably going to be either busted or fried. Either one. So when do you select the right module is just based on the motherboard, and that's a good thing. And yes, Nicole, that's a good question. Yeah, there is a limit of how much RAM on an OS. Like we discussed before, if you have a 32-bit, it can only support 4 gigabits. And in a far future lesson, we're going to explain that. I think maybe we'll explain a little bit of that in detail today, actually. You're going to show us some math, actually. Remember we're learning about bits and bytes? 32 bits times, well, the power of 2, basically. The power of 2 by
it's
32.
binary. That gives you 4 gigs. 4 gigs. That number right there is 4 gigs.
Now, if you put 64, 2 to the power by 64, that is also your limit for a 64-bit operating system. Now, that number is
1.8. 19 zeros behind it.
That's a lot of power. So it's a big upgrade from 32 versus 64. Big upgrade. This is why you don't usually see 32 bits nowadays.
Now, fair warning, in the operating systems, there's still, although they may be 64-bit operating systems, you got to look at the version of the operating system, because some of them are still won't give you more than 16 gigs or 32 gigs or 64 gigs. They won't give you the full one. I know that Linux does, but I know also that Windows, depending on which one it is, won't give you the full. So like the Home Edition, for instance, although it is a later and greatest one, the Home Edition won't come with the capabilities of holding that much RAM.
That's correct. And that is a good question I have here right now, Feldy. When it comes to the page, when it comes to the RAM, meaning Windows operating it, it's all automatic. There's a formula that Windows uses for it to know, and the BIOS will usually kind of kick in when it's time to communicate as well. So long story short, it's magic. It's kind of complicated. It is beyond the CompTIA A+ though, on how the RAM does it. It's more programming. Okay. Now, there is a lot of stuff we talk about here. Is there any questions so far?
No.
How does the computer... I'm sorry, what was the question from Fadil? How the computer choose the page file when run multiple RAMs? Remember, the page file itself is automatic from the operating system. The page file is what the operating system is going to create. A rule of thumb, it is usually 1.5 the amount of the current RAM. That means that if you have 8 gigs of RAM, your page file, the maximum size will be 12 gigs of RAM. This is just something as a rule of thumb for you to understand and how it works. You just need to understand what a page file is and what it does for RAM. That is the key understanding of what it is. Understanding its size and everything else, not that I'm aware of. They're not going to throw a curveball like that.
Yeah, I don't think they're going to give something that complicated. Just like Diego said, just know about that rule, 1.5 times the maximum RAM that you have. You should be good for the exam. And also the blinking lights you see. Excessive hard drive means you already meet your limit of RAM. You need more actual physical RAM. The virtual RAM is doing all the work and it's not going to last very long. Okay. Let's see here. What's next? This is actually a very good question. And matter of fact, I'm trying to buy a computer from my mom, and this question comes all the time. How much memory do you really need? So let's take a look here. Okay, I got a question here. I mentioned two power last mentioned earlier. Oh, sorry. That's for somebody else to handle. So like Nicole was mentioning about the OS, because she had a question about the 32 versus 64, you can see that you need at least 4 gig. Well, sorry, I'm saying it wrong. Like Nicole was saying, with a 32-bit, you have a limit of 4 gigabits, just like we showed on the screen when Diego was giving us the math. 2 by the power 32 gives you that limit. And it's also important to mention, you need to know how much RAM you need for Windows in general. And this is referring to Windows 8 and 7. You need at least 2 gigabits. More the better. It says you can run 2 gigabits, but trust me, you need usually more than 2 gigabits. And for example, over here with the 64-bit installed, it can handle more, of course. You see here, Windows 8 can support up to 128 gigabits of RAM. And like Diego was mentioning with the Home Edition, you can only go up to 16 gigabits of RAM, specifically Windows 7 Home Premium. Believe it or not, when we go to the second core of our lecture, that's going to be in the next, like, I believe 3 weeks, we will be talking about the additions of Windows, because they do come up in the test where they ask you what are the requirements, and sometimes even ask you what is your limit of RAM. And sometimes your addition does matter. So that's a keynote for the future. So let's take a look over here. It's time to climb. All right, I want to see my penguin warriors. I'm gonna do a little bit of activity here, see how everybody does. All right, let's get it started. Pick your characters. Got a question here. No 1 gigabit. What do you mean by 1 gigabit? Talking about the requirements? All right. So which requirement are you referring to? You're just referring to Windows in general? Because if it is Windows, you need to know which version.
Yeah, you said Windows 8 and the 7 at least 2 GB.
Sorry, say it again. I couldn't hear you.
Windows 8 and the 7 at least they need 2 GB. Is that the minimum?
Hold on. Sorry, I can't hear you.
He's asking, is Windows 8 and Windows 7, what's the minimum amount of RAM needed?
Oh, okay, that's a question. So depending on its bit version, also matters. So if it's 32-bit, I think it's 1 gigabit, and then if it's 64-bit, it's 2 gigabits. Let me double check that.
Yeah, and we won't need to know that for this part of the exam. The exam won't be asking you the operating system minimum requirements. That will be in the 1002 portion of A+, where they will ask you for every single version of Windows, its minimum requirements to be able to run. So don't really kill yourselves at this point trying to memorize that.
Agreed. It's a lot, but it's a good question to even mention. So you have that in the back burner. So when you see it, you won't be too surprised. I hope. Are we ready to climb? I think we're missing some people. I give you like about 10 seconds. And then I'm going to start anyway. Oh, I knew we were missing somebody. All right, my current computer uses Ddr2. I want to upgrade it with Ddr3 on the same motherboard. Will it work? Will it work? I wonder. Same motherboard. I mean, it is an upgrade, right? I want the latest and greatest. All right, let's see the results. The answer is no. We'll go back to that question why if anybody got that one wrong. All right, the maximum amount of RAM a 32-bit system can have is 4 gigabits. I wonder if that's true or false. I'm expecting a Pacific person to get this right away too. All right. Answer's true. 4 gigabit is the limit. All right. This game feels weird without the music, don't you think? Now this one's a hard question. How many pins does a DDR3 SODIMM have? Now we didn't really mention it too much, but if you get it, I'll be happy. You can also click on the picture to get a tip too, by the way. All right, that's a hard one. People seem to do a good job on that. That's good. All right, which RAM is faster? Big tip. There is no DDR4, so I recommend you click the picture and you pick the ones that you think it's right. And believe it or not, you may get a question just like this on the exam. Almost, not almost exactly, but kind of similar. All right, good job. All right, the tiebreaker. Which DDR1, 2, 4 have the same amount of pins? This one's also very hard. Who can get this one right? It's not easy. You can always Google, I guess. I see somebody trying to Google, I think. Oh, yours is not loading yet? Uh-oh. All right, good job, Nata. I'll take a look to see why yours wasn't loading, Benjamin. Sorry about that. All right. Good job, everybody. I know the last two were very difficult, but we will be actually reviewing those shortly. So just in case you didn't get it, we're going to go through it. Good job, everybody. I'm very surprised how well everybody did. Very good. That's right. All right, now we're going to talk about what me and Diego were mentioning about the RAM that you can see. So you can see here in Windows, you can go to the System Control Panel, and you go to your system, you can see how much memory they're installed. You see it's highlighted. It has 6 gigabits, and 5.88 of it is usable. That's just what Windows tells you. That's what Windows letting you know that, hey, this is how much I got to use. And then you have, from the BIOS setup screen, you have its information that it tells you, hey, this is how much RAM I have. And it even gives you more detail. It can tell you which channel is in use, what is the gigabit. Heck, even tells you the memory speed. And this one, it looks like you can even turbo speed, meaning it could maybe potentially be overclocked. You don't need to know about overclocking yet, but that's such interesting. But what I really want to talk about is the third-party software. It is true that most third-party software will have far more detail than most operating systems and the BIOS. And I'm going to show it here in the screen of a program called CPU-Z. So I'm going to break the share so I can share the CPU. Let's see here. Let's see here. Let me see if this works better because it's a pretty small program. Does everybody see it pretty well? All right, I got thumbs up. So I love CPU-Z. This will tell you a lot of information. Right now, I'm going to check the memory here, and it can tell you what type of memory you have, how much the size, even tells me what channel I have and what is running right now. It's running about 36 megahertz. And look, remember this? Does anybody remember what LC means?
The clock speed.
Cast latency.
Yes, this is the latency. This is what you're looking for when it comes to clock speed. Matter of fact, you can see different ones here. This is all my combined RAM, and this one right here is telling me this specific RAM is running about this kind of frequency here. As you see, it goes up and down depending on what I do. And you see, there's a lot of other information that we did not go through. And the reason why is that we don't need to know this. This is a lot of detail. If you are a programmer, this is stuff that you would need to know. But we're not doing any programming, so you don't have to worry about that. And then now we're going to head over to the SPD. Does anybody remember what SPD is? We mentioned it. Anybody? I had somebody ask a question about it before.
That little chip that runs during post and checks how much and what kind of memory is there. But I have don't remember what it stands for.
You're correct.
Serial presence detect.
And Benjamin got the exact name too. Believe it or not, it is possible to even access it after boot. You can see here I have access to it. I can see slot 1, slot 2. It tells me exactly what it is capable of doing. I have 8 gigabits. It even tells me the week, its rank, manufacturer, part number, serial, and all these tables here you can see. You can see here it has like number 8, 9, 10, 11. Personally, I'm not sure what that means, but I would be assuming that this is related to the cells on the chip of the RAM. Like I said, this is a lot of detail you don't really need for the exam, but now you have an idea of where that is all stored. It is on the SPD, and this third party from CPU lets us have that ability. So I'm gonna give it back to Diego to share screen, and we go back to the main menu, our Nearpod. So that is our third party software. It's really cool. There's another one called SpeedFan 2. That one is for other kind of uses, but those are the most popular ones you may actually run in the future when you start studying CompTIA A+. Start finding these softwares that help you understand how the hardware works. All right. Now, how do I install the new modules? Now, this is talking about how to actually install the RAM. So just like we mentioned before, you unplug the you unplug the computer, you make sure there's no power, unplug it, you remove the module with protection, your ESD protection, make sure you don't damage anything, take it out of the little notches that you see. Let me show you what those notches look. These are the notches. You gotta take it out, boom, swap it out, put it back in, and you're good to go. Nice as peasy. So right now, I'm gonna pass it to Kelly. Kelly's gonna help us out right away.
All right. Some of the pitfalls you may run into while installing your memory. The memory doesn't seat properly, doesn't snap in. One of the first things you may notice is it's an incompatible board. As we were talking about earlier, they use different pin numbers, they use different notch positionings when using different kinds of RAMs, so you don't use incompatible RAM modules with motherboards. And general rule of thumb, I think we've mentioned it before a couple of times, when you're seating that memory, if it doesn't go in easily, if it's not sliding in smoothly, do not force it. You will break it. So you need to be very careful when doing these things. Also, to make sure that you're not using incompatible units, got to check your documentation. That's always a good rule to have whenever you're upgrading any components within your computer. You want to just verify within the documentation that what you're using can be used with the particular systems and setups that you have. That way you don't have a catastrophic failure or waste money trying to order components that won't actually work for your needs. So other things, say you've got the RAM, it installs perfectly, you put everything together, turn it on, nothing. You don't get the boost you need, you go in, you check it, computer doesn't even see it. Main thing you want to go to is go back to the BIOS where last row I was talking about. You go back, you make sure that the bank is turned on, because if it's not turned on, the computer's not going to see it, it's not going to recognize it, and thereby you will not get the added benefit of the additional RAM that you have installed. And then if you only get like half of the RAM module in and it clicks, you think it's seated properly. This is a common thing that happens when you're installing the RAM, where you only get one side in and the other side doesn't quite seat properly. It may not boot at all, because if you've only got 2 RAM modules and you have them set in tandem to work as a pair, and one of them is not seated properly, it's as if you don't have any in there at all. So your system won't boot up at all. You just get a straight post error, and then you basically have to break the computer back down again, check your RAM modules and make sure you didn't put them in different banks. So you didn't put one saying bank A1 and one in bank A2, when the motherboard requires you to put one in A1 and one in B1. So if you put them in opposing banks, again, the system won't recognize it if it's expecting two modules to work in tandem. Some of the fun warning signs.
Sorry, I have a question, if it's possible. So if I have 2 of the same RAM and I have more than 2 slots, how do I know into which slots I install first? I mean, it's color coding to show 2 of the same, but which 2 of the same?
Yes, that the color coding would be the first indicator, because a lot of times on the motherboard they do color code them. Like sometimes you'll see one bank will be red, one bank will be black. I've seen tan and black or white and black or something like that, just to kind of distinguish those 2 banks. But the fail-safe is definitely looking at the documentation for your motherboard, because within that it will tell you if you're installing more than 1 RAM, or if you're installing 2 at the same time and you're wanting them to work as a bank, you would need to install them in these particular slots. They may say from left to right, it'll be bank A1, A2, B1, B2, C1, C2. And then they'll tell you, you need to install the RAM in A1 and B1 if you want them to operate in tandem. So when all else fails, always look at your documentation. That'll tell you. And I believe even in the BIOS it'll tell you. So definitely something.
Thank you.
It's also written on the motherboard, physically written on the motherboard.
Yeah, or you could check there too. Yeah, it's easy to forget. I've done it myself many a times. Is everything that you need to know is etched very, very in very small writing on the motherboard. It'll tell you what everything is, where it is, and makes it kind of easy for you to figure out where stuff goes. Typical warning signs: if the RAM isn't functioning properly, isn't seated properly, or you put them in the wrong banks. Big one, everybody always loves it, is the BOSOD error, the blue screen of death, which is pretty wonderful, because when you get it, what is the main feature of the blue screen of death? Do you get it just for anything, or, can anybody tell me exactly what it does for you?
I think it gives you error codes.
Perfect.
Pretty sure. Yeah.
Yes, it does give you error codes, and then you can look up those specific error codes, and it will tell you exactly what's wrong with that computer and help you along in your triage process in trying to fix it. Although I have seen on some of the newer computers, we actually had this happen in our group, where as you're booting and it goes through the splash screen, the BOSOD, the blue screen would pop up for literally a second and then keep moving on. And it wasn't long enough for you to be able to actually document the error. Again, that's where it comes in handy to have something like your phone. You could literally just record the boot process, and then you just pause it when you get to the blue screen and you can see what your error is. System works fine when you first start it up. It begins to have problems a little later. It starts bogging down much sooner than it normally would. That's another great warning sign. Freezing, hesitating, system moving slowly, and it does not boot up at all, and you get the fun post error. And real quick, what does post stand for? Someone? Anyone?
Power on self-test.
Very good. And if it doesn't come on at all and you get, say, 3 short beeps and a long beep, what can you do to figure out what it is?
Look up the
Go to the manufacturer website.
Very good. Go to documentation, manufacturer website, Google, all sorts of fun, different places you can go to get extra information that will also help lead you to the solution to the problems you're having. All right, basic solutions. Oops. Thank you, Diego. Basic solutions to problems. If you're running slow, one thing you can do, you may have multiple processes running, and just do a basic restart. That's why one of the first things a technician is going to ask you to do a lot of times is say, have you done a restart? Because it's amazing how many times that actually clears up the actual problem, because it clears out the entire RAM menu. You may have 37 windows open on your Explorer website. You don't realize it because you haven't minimized, but all those websites are refreshing in the background, each one of them eating up a little bit of RAM at a time. And then over time, you essentially lose all functionality because you have all this stuff running in the background. You do a restart, those websites don't start back up with your computer, and voila, problem's fixed. All right, who wants to, Andre, can you please read for me, sir?
Warning signs and troubleshooting. Solutions to try for replacing. Rebooting system to clear RAM memory. Enter BIOS and set post to disable abbreviated start to check for memory issues. Check memory in another system. Checking for overheating, dust, faulty fans. Test power supply for failing, overloaded, or overheating. Testing using software, website, troubleshooting, or a video utility program to be sure it is a memory issue.
Excellent, thank you. Yeah, with almost any component, you don't necessarily know if it's your board failing, the bank failing, or if it's the actual part failing. So one of the quick things you can do with almost any component in the computer, if you have another compatible system, flip it out and plug it into another system and see if it works. That way you're not throwing away a perfectly good component or replacing one that doesn't need to be replaced. The issue may be you think that the RAM module is bad just because it's not being recognized by the computer. So you take it apart, you reseat it, still not working. You get frustrated with it. So you're going to try to grab another RAM stick, put another RAM stick in there. It still doesn't work. And then come to find out, you could have gone into the BIOS and realized that the banks are disabled. But if you took the unit, plugged it into another computer, you see it works just fine, then you know that that's not your particular issue. There's something else going on you need to look into. So oftentimes when troubleshooting, you're trying to be essentially a detective. You're trying to not just look at necessarily the symptoms, but see where those symptoms lead you. All righty, I think Lazaro went over this one, but we can probably run through it really quickly. Ayana, can you please just read number 1 for us? First step in adding or removing RAM from a computer.
Shut down the system and remove all exterior cabling. Press and hold the power button for 5 seconds to drain any remaining power.
Excellent. Number 2, Muhapa, can you please read for me, sir?
Number 2, be sure you are wearing your ASD strap.
Excellent.
Open the system case and locate the slots for the memory modules.
Wonderful. Natalia, can you please read number 3?
Remove any data cabling and other devices preventing you from accessing the slots. How many modules are currently installed? Are there any empty slots to install an additional module?
Excellent. For Benjamin, can you please read for us, sir?
Notice that the slots have a retaining mechanism at each end to secure each module in the slot. Modules are inserted and removed straight up and down. Spread the plastic levers apart before inserting or removing the memory modules.
Thank you. 5, Elizabeth.
Hello, can you hear me?
Yes.
Okay, good. Okay, number 5. Examine an empty slot and note the raised ridges that line up with the notches on the memory module's pin edge. Because modules are designed to be inserted in only one orientation, these ridges prevent them from being inserted incorrectly.
Excellent. Thank you.
Thank you.
Number 6, Kevin.
If you're inserting a module, verify the module is oriented correctly to the slot. Insert the module and gently but firmly push it in. If you're removing a module, carefully spread the levers apart and remove the module.
Excellent. And lastly, number 7, Yusuf, can you please?
Reassemble your system, turn on the computer, and verify the correct amount of RAM is shown.
All right. You are going to want to commit these steps to memory as much as possible for the exam, just to kind of, help you get an idea as what comes, next after each individual step. You'll notice a lot of this is similar to disassembling and assembling a computer. A lot of the steps are the same and the general order is the same. So before we get to the video though, real quick, because we want to rehash it, what should you do to protect both yourself and a computer from harm when installing or upgrading the memory within the computer? It's a multitude of things, but what do you think you should do?
Use an
ESD
anti-static
strap.
tool.
ESD?
Turn off
Take
the
off a
computer
jury.
first, unplug it, then and
Perfect.
press the start button for 5 seconds.
Unplug it, press the start button for 5 seconds and turn it off. What else might you do?
Take off any jewelry.
Perfect. There you go. From the quiz from this morning.
Tie loose hair.
Tie loose hair back. There we go. Excellent. I like it. And then in general, what will you do, thinking of your behavior skills and mindsets, what will you do to kind of ensure you are prepared to work on a multitude of different machines and with various issues? What will you personally do? What behavior skills and mindsets will you employ?
Adaptability and persistence.
Okay. So you're adapting. Okay. Anything else you might think we might need?
Growth mindset.
Growth mindset. Why?
Growth mindset. To be able to learn new things. You might not be as good as it in the beginning, but you'll get better with it as time goes on. So more effort.
Absolutely. Because as Diego put it when we first started the course, welcome to the first day of never-ending learning within this industry. It's constantly changing, constantly updating. Are any of you familiar with Moore's Law?
Yes, it's oh darn, I forgot the word just now, but exponential growth. Every couple of years, the amount grows exponentially of how advanced things are. Is that the one?
I like it. Yeah, Moore's law was basically, it's kind of an observation. It was notated back in the mid 60s that technology, the speed of computing will double about every 2 years. And interestingly, we have kept that up every 2 years since the 1960s. If you think about that, I mean, before, you know, at that point we had computers as big as a room that could barely do multiplication tables. And now you essentially have the wealth of human knowledge in your pocket. So I guess right now we have a couple of videos from Professor Messer just to kind of review what we've gone over for today. If you are able to hear it, let me know.
Describes memory, or somebody asks you how much memory is inside of your computer, they're referring to the amount of random access memory, or RAM. We're not describing the size of an SSD or the capacity of a hard drive. We're referring to the components inside of your computer where all of the transactions are taking place. When you're using the programs and the data on your computer, they're moved off of your SSD or your hard drive and they're put into RAM so that you can perform calculations on that information and then store that information back on the SSD or the hard drive when you're finished. Your desktop computer or your laptop will have slots where you can install the random access memory modules. The different motherboards may have different types of slots, but it makes it very easy to add, remove, or upgrade the memory that's in your system. The process of moving information in and out of memory is happening all the time inside of your computer, so the faster memory you have, the faster the overall performance will be of your computer. Every motherboard will be a bit different on how fast these transfers can occur in and out of memory. So check the documentation of your computer to see exactly how fast you can expect your memory to run. The type of physical package that installs into those slots on your motherboard is a DIMM. This is a dual inline memory module. It's called a dual inline memory module because this memory module has a series of contacts on one side of this module. It has another set of contacts on the other side of the module, and those two contacts are different on each side of that memory module. These dual inline memory modules have a 64-bit data width, so we're able to transfer data from these memory modules in chunks of 64 bits at a time. The memory that's inside of a laptop is probably a smaller version of the DIMM. This is the small outline dual inline memory module, and it's about half the width of a standard DIMM that you would find in a desktop computer. You can find the DIMMs and the SO-DIMMs available in DDR2, DDR3, and DDR4 flavors of SD-RAM. We'll explain what all of those are later on in this video. If you're using a SO-DIMM, it's probably inside of a laptop or a mobile device because of the size. You're able to fit a lot more information into a smaller area, which is important for those mobile devices. Here's a good size comparison of these two. The DIMM is the larger memory module that you would find in a desktop computer, and the SO-DIMM you can see is about half the size, and you would find that in laptops and other mobile devices. The type of random access memory that is on these DIMMs is called a dynamic random access memory. It's called dynamic because it constantly needs to be refreshed. This is very different than the type of memory you might have in a flash drive where you would store information and then unplug it to move it to another computer. That flash drive doesn't need to be constantly refreshed to maintain that information. But the memory that we use inside of our computers is a much faster memory, and it requires this constant refreshing to be able to maintain the data that's on those DIMMs. If you were to power off your computer and no longer able to refresh that memory, everything that was inside of those DIMM modules would soon disappear. The use of the word random inside dynamic random access memory is because we can access anything in that memory at any place at any time. This is very different than how we used to access information on a magnetic tape, where you'd have to wind through the tape to get to the section that you need to read. With dynamic RAM, you can simply specify an address, grab that information, and then be able to access that data. The type of dynamic random access memory that you would find on today's computers is a type called synchronous dynamic random access memory. It's synchronous because it is synchronized with the common system clock of your computer. The standard flow of communication based on these clock cycles allows the system to queue things up in a very standard format. This is different than earlier types of dynamic random access memory where there was no synchronization. But in today's desktops and laptop computers, all of the memory that we're going to be using will be synchronous DRAM. Here's the way that we're able to use these clock cycles to be able to pull information off of this memory. In a single data rate memory, or SDR, we have a single clock cycle. You can see the up and down wave of the clock cycle, and there's a number of clock cycles listed on this diagram. And through each single clock cycle with the single data rate memory, we can pull 1 bit of data, which means if we have 1, 2, 3, 4, 5, and 6 different clock cycles, then we can pull 6 different pieces of data. With dual data rate memory, we still have the same clock cycle. Things haven't changed as far as the clock going up and down and having those 6 different clock cycles. The difference with double data rate memory is that we're able to pull information on the upside of the clock cycle and the downside of the clock cycle, meaning that there's 2 different bits of data that we can gather in the same clock cycle. That's where the double in the double data rate comes from. In older computer systems, you might even find double data rate generation 2 or DDR2 SDRAM. These are memory modules that were faster than the original double data rate memory modules, and they're not backwards compatible with those. In fact, they're not forward compatible either. If you have a computer system that requires DDR2, then you must use a DDR2 module in that system. You're not able to replace it with a DDR, a DDR3, or a DDR4. The generation of memory after DDR2 is DDR3, or double data rate 3. Ddr3 Ram has twice the data rates of DDR2, so greatly improved performance for those systems that could support DDR3. It also improved the maximum size on a single DIMM to 16 gigabytes of memory. And again, if you have a motherboard that requires DDR3 memory, then you must use a DDR3 memory module. You can't take the DDR2 modules from an older system and move them into a DDR3 system. They won't fit into the module slots at all. One of the newer generations of DDR memory is DDR4. This 4th generation of memory has speed improvements over the 3rd generation, and it increases the maximum size of a single DIMM up to 64 gigabytes per memory module. And as you might expect, the changes with DDR4 also mean there's no backwards compatibility to earlier versions of modules either. Not only did we change the technology between these different generations of DDR memory, but we also physically changed the package. So when we say that it's not backwards compatible, it's not even an option. You can see there is a key or a small slot that's inside the memory module, and the slot is in a different place in each generation of memory type. This means that if you have a motherboard that expects DDR4 memory modules, this is the only type of memory module that will physically fit into the memory slot. If you're trying to install a memory module in a computer and you notice that it's not fitting perfectly, it may be because you have the wrong type of DDR memory.
Or like they like to say, if it doesn't fit, you must acquit. Therefore, can't use it. Nobody.
The memory that's inside of our computers is not infallible. You can have electrical hiccups. There could be memory that is not seated properly, or there just might be bad connections for the memory that's inside of your system. And occasionally there might be a bit that accidentally gets flipped from a 1 to a 0 or vice versa. If you have a critical computer system, however, you really can't afford to have memory that might be changing some of the values as it's going through the computer, regardless of how rare that might be. So your virtual machines, you might have database servers or web servers or systems that are required to be up and running all the time. Because of that, we have a type of memory that's able to check itself. One of these types is called parity memory, where it adds an additional parity bit to the information that's associated with a byte that's going through your computer. Parity memory is great, but it won't find every possible scenario. For example, if your memory becomes corrupted in a way that the parity is still correct, then it's not going to notice that there is anything wrong with the information that's inside of that memory. And parity memory is not designed to actually correct anything. It can only inform you that a problem has occurred with your memory. A type of memory that is able to make a correction is called error correcting code memory, or ECC memory. This is not only identifying that there has been an error with the memory of your computer, but it's able to correct that memory on the fly. Not all of your computers are using ECC memory. In fact, very few of your computers are probably using memory that is ECC memory. The ECC memory is a bit more expensive, and it's really designed for those enterprise type systems. So a very large server may have a motherboard that requires ECC memory. In fact, it won't work unless you install ECC memory into that device. It's sometimes difficult to tell though, because the memory looks identical to non-ECC memory. So make sure you keep your memory modules together with the documentation that came with them, so you'll know exactly what memory type you're working with. A lot of people have asked me what this parity bit really means, so I created this diagram to show how parity works inside of our computer. These parity bits inside memory are usually even parity. That means that the parity bit is making an even number across all of these bits that are inside of our systems. Let's take an example, for instance, this first byte that we have at the top, and a byte is these 8 bits. So with these bits 1 through 8 are 1110, 0111. The way that parity works is it will examine how many ones happen to be in that byte. So there's 1, 2, 3, 4, 5, 6. And since that number is an even number, the 6 value is even, we don't need another 1 associated with that, so the parity bit is going to be 0. Let's look at the next byte. We have 00000010. Well, we can see we only have a single 1, so this is currently odd number of ones. So to make this an even number of ones, our parity bit would now be a 1. And that's how we're able to determine whether the parity inside of this particular byte is correct. Let's do the last byte. We have 1001, 1000. If we count the number of ones, we have 1, 2, 3 ones. That is an odd number. So we know that we need to add an additional 1 for this entire string that makes this an even parity. So now that you have this parity bit associated with this data, how do you determine if anything has gone wrong with the particular memory byte? Well, let's have a look, for instance, at these examples. You can see we have a byte and a parity bit associated with it. So let's do our calculation again. Let's count the number of ones inside of this byte. We have 0000, 0111. There's 3 bits, and a single parity bit was added to make this an even number. And since we have even parity, that particular piece of memory is exactly correct. Let's do the next one, 0000, 0010 with a parity bit of 0. And if we're evaluating that, you can see that we have an odd number of ones, which means something has gone wrong with this memory. Because our parity bit was 0 and we have an odd number of ones, we know that something went wrong with that section of memory. And let's do one more, 0110, 0100 with a parity bit of 1. And if we count the number of ones, we have 1, 2, 3, 4 ones, which is an even number. So we know that that piece of information in memory is absolutely correct. Another memory characteristic you may run into is memory that's described as registered memory. This is memory that has a buffer inside of the memory. There's an additional register inside of the memory, and there's a buffer between the memory itself and the memory controller. You'll see this sometimes referred to as buffered memory because that really is describing what's going on. This is obviously one that's used on very high-end systems. So you'll see this on servers, on systems that need a stable operating environment. You will rarely find registered memory requirements on a machine that's simply a laptop or a desktop computer. You can sometimes identify visually when you're using registered memory because there may be additional chips right in the middle that's used as the buffer itself. In this case, this particular memory has a sticker on it that shows the type of model, and you can see this is a 512 megabyte memory. It's DDR memory running at 333 megahertz, has a CL value of 2.5. This is ECC memory, so this is error correcting memory, but it is also registered memory. You can see the REG that's right there. And these things can be used together. You can have ECC memory that is not registered, and you can have non-ECC memory that is registered. But it's very common to see ECC memory and registered memory being used together in this way, especially if it's going to be used on a high-end system. If you're putting memory inside of your computer, you may want to see if your motherboard supports multi-channel memory. This is where we can install memory in pairs or in trios, and it maximizes the throughput of that memory in and out of those memory modules. And this may be important, especially if you're doing some high-performance computing. You're going to want to have the fastest possible throughput by simply adding the proper number of modules onto your motherboard. These memory combinations should also match. You should ideally have exactly the same memory types that will be used in these different channels of memory. You'll often see that the memory module channels are also colored. So you would put the same type of memory modules in for each of the colors. In this example, this is a motherboard I have that is a dual channel motherboard. And you can see that you would put one of the memory modules in black and the other part of the dual channel would be in the other black module. So if I wanted to maximize the throughput in and out of memory on my motherboard and I only had two memory modules, I would make sure that they are installed into the two memory module slots that are colored exactly the same. One characteristic of memory is whether it is single-sided or double-sided memory. And there are unfortunately a couple of ways that this can be interpreted. One is very literally. You could have a memory module that only has chips on one side of the module and no chips on the other. So in that case, it would be a single-sided memory module. But some memory modules will have memory chips on both sides of the physical module, and some people will refer to that as double-sided memory. But there's another way to interpret single-sided versus double-sided memory that really doesn't describe the physical package of the memory itself. In this case, we're really referring to the ranks of memory. Ranks is how we separate memory on a single module so that they can be accessed with the memory controller. Sometimes these separate ranks are called sides. So you might have a single-sided or double-sided memory referring to a single rank or a double rank on a memory. These would really be separated out into two different pieces. This, for instance, might be a memory module with two ranks, and you could easily describe that also as two sides. So you really have to ask a person who's talking to you about single-sided and double-sided memory of what they're referring to. Are they referring to the physical package of the memory on the memory module, or are they referring to the ranks of memory as it's accessed by the memory controller? If you're looking to upgrade the memory inside of your computer or install some onto a new computer build, you may go online and see what's available. And you can very quickly see there are many different kinds of memory specifications. Memory has a very tight tolerance. You need exactly the right memory for your motherboard. So your first stop should be your motherboard documentation. This will be the absolute authority to determine what type of memory you need to purchase for your motherboard. If I look at the manual I have for my motherboard, I can see that mine says 4x DIMM, which means there are 4 DIMM slots in my motherboard. It will take a maximum of 32 gigabytes of memory. It is expecting Ddr3 1600/1333 megahertz, so I can get either speed of memory to go inside of my motherboard. And it's requiring non-ECC, so it's non-error correcting code memory, and it is unbuffered memory or non-registered memory modules. I have to make sure I get exactly this specification so that it will work properly when I install it into my motherboard. Fortunately, a lot of the sites where you can purchase memory online will also have online guides. So you can put into their website the make and the model of your computer, and it will give you a number of options that are available. And you can then cross-reference the options that they're telling you against what you see on your motherboard documentation and make sure that they sync up. If you look at the search results online, you may find that you have many different options available. Even for my motherboard, I could put Ddr3 1600 memory, or I can put Ddr3 1333 memory. So it's different speeds available. Of course, the 1600 memory is faster, and it's probably going to be more expensive. But if all I need is a system that is performing simple web browsing, maybe I can save a few dollars and get the slower memory, but still be able to have a memory upgrade and capacity that I'm looking for.
Okay. Hopefully that helped reinforce what we just went over. He explained briefly what we were just reviewing. And hopefully, as we stated, we'll be also posting these videos and or the Nearpod sessions out there for you guys to be able to download and view. Let's go into the actual little fun quiz here. So, questions Number 1. Shiloh, if you can read that question for me and help us try to answer.
If the RAM value has not changed after install, what is likely the problem?
Playing the game that we said earlier, let's eliminate what is the not correct, whatever is not possible. Would a post error be the problem if you did not change after you installed something? Would that be a post error? In other words,
No.
originally you had 8 and it keeps on saying 8. Next one, RAM not reached parity. All right, that sound right?
No.
Okay, we can eliminate that guy for now. C, it's not installed correctly. Can that be a right option?
It could be, I think.
Yeah.
Okay, so we got 1. And last one, D, there is a bad swap file.
No.
Not possible. And thanks to Spock, we should all be able to eliminate all the impossible, no matter how impossible it is. Therefore, that is the only answer left. Has to be, no matter how improbable. Next one, if RAM does not fit easily, you should rock the card back and forth. Rock the boat. It should fit right
False.
after that.
False.
False.
Why is rebooting an effective troubleshooting technique?
C.
Clears RAM memory.
Okay, everybody agree? Let's see. A, the computer reinstalls the OS. Interesting. That sounds very interesting. It brings the computer back to factory settings. Interesting. Kind of sounds silly right now when we hear these things and we understand what it does, right? Buys time for the technician. I like that one.
that.
I like
like
D
that
though.
one.
I want D. Can I select D, please? But yes, as we can see, these are easy to spot, but we need to play these games because it's going to be harder when we get the actual exams. What is the first step in installing a new RAM? So turn off the power, examine the card slot, remove the case, remove the data cable. Which one do you think is the first one?
A.
Oh, turn off the power.
Turn off the power. Would have to agree with that. Last one, which is not an indicator that you need more RAM. So is it, if it's generally slow, is that a yes or no?
Oh.
Yes.
Okay.
Yes. That's indicated.
B, is that an issue with RAM?
Yes.
Fan running constantly, is that an issue with RAM?
No.
Unlikely.
Okay. Excessive hard drive access?
Yes.
Yes.
See.
Only thing left here, what we said, the only one out of these could be is then the fan, because of the word not. It's the only thing that we should be hopefully looking for.
I have a question. So the answer was not excessive heat, and I got it right, but I was just wondering, I know that the questions are always like pick the best answer. Is that at all true? Will heat ever be a byproduct of running low on RAM?
Heat would be your CPU running hot or poor circulation. Your RAM would never heat up that I'm aware of. Not aware of ever RAM heating up.
I think she might be talking about, I may be wrong, but continually accessing the hard drive, causing the heads and the disks to continue moving may cause additional heat, but not enough to where it would cause the fans to continually run.
The only thing I can think of is overclocking the RAM, which I don't think people do that nowadays.
Either which way, what they're talking about, the fan running constantly, is in reference to cooling the CPU. even no matter how fast I pump this circulation of air, you have to understand that either it's the air that's going through the case, correct? Because it has a fan in the back that sucks out. On the high ends, you have like 3 fans in the front and I don't know how many fans in the back, and it just flows the air in and out of there. Then you have the extra fan that's on the CPU, and you have another fan that's on the PSU, which is the power supply unit. Those are the only fans that are inside the computer. Therefore, the fan running constantly doesn't say anything about the performance of the RAM itself. Only says about the cooling of the computer itself. I hope that helps.
Yeah, thanks.
Okay, so at this point, hopefully we should be able to define system memory itself and the different technologies. Articulate the process overall, including the key questions to answer when you're upgrading it. Understanding that obviously that RAM holds the data and instructs everything that's going from the CPU to itself, or even coming from the hard drive itself, right? Determine when to purchase and what are the right modules. As we said, we got to go and look at the actual uh, motherboard manual, be online or wherever it is, to be able to decipher what is compatible with this motherboard. Summarize overall, hopefully, how to install, identify our common pitfalls and or problems. Any questions or doubts? All right, stop my share here and the recording for this session.